Everyone is welcome to my YouTube channel on the topics of AVL tree. What is the AVL tree? Before we already discussed on the topics of B tree, binary tree, and also binary search tree. Now we are discussing on the AVL tree. Binary search tree is also a binary tree, special type of binary tree, and AVL tree also a binary tree, a special type of binary tree. But what is the difference? The simpler difference, if we know, then will be easy to understand the AVL tree. B tree is also a tree. B tree is also a tree where children depends upon the order of the tree. Maximum children, if order is 5, then children is 5. Minimum children, 5 by 2, that is 3. In case of binary tree, the maximum children is 2, minimum children 0. So any node can contain 0 children, 0 child. That is, this node is a binary tree, or this is a child of this binary tree. This child does not consist one child, and this child consists no children. This node contain another child, maximum 2 child in case of binary tree, and this node contain 0 children. This node contain 1 children and 1 children. So this node contain 1 children, this node contain 0 children, this node contain 2 children. So the binary tree, in case of binary tree, maximum 2 children, minimum 0 and 1 possible. But there is no such rules to enter data. Suppose you can enter here, that is x minus y into. You can enter any data at the binary tree. Suppose the value of this, after entering data, value of this t is, in case of in-order traversal. In-order traversal, we get the data x minus y into. Just according to the node, the value is calculated. But in case of binary search tree, value restriction is there. We can't enter any types of value. Value depends upon the comparative ascending order, descending order. Suppose if we enter here 20, the left side will be less value and right side will take the greater value. Right side greater value, left side lesser value. But this is a restriction, only this one a restriction of the binary search tree. And if we want to enter data, if this data entering, it depends upon the order. Suppose this is the order of the one binary search tree to enter data. So first we have to enter 50, 50, 30 is less than 50, 30 is 30, 20 is less than 30, this is the next data, then 10, 10, then 5. 5 is less than 10, that is left child will be generated, 10 left child of the 20, and 20 left child 30, 30 left child 50, because the value is decreasing. If this order is changed, that is, suppose the order is 20, 30, 10, 50 and 5. This is the order. The order is changed, value is not changing. Then the graph will be changed. So first we have to insert 20, then 30, that is right side, then 10, that is left side, then 50, that is right side, then 5, that is left side. So if we want to search 5 at this graph, at this T, then we have to search 1, 2, 3, 4. 4 nodes. Then we are reaching at the 5 position, at the point 5. But here we are searching 1 to 2 nodes. So different graphs and searching time is different due to different order of the binary search tree. This is the difficulties of this is the limitation of the binary search tree, where the ordering is the possibility where to search the data. But in case of AVL tree, this is not required. AVL means height balance tree. So this is one AVL tree. Suppose this is one AVL tree, also a binary tree. And this AVL tree is balanced or not, it is first we want to know. So this is a node. Suppose this is the node B, this is the A, less than A, greater than C, C is greater than B. So right side. A, at the position A, you have no child, so no child. So A balance factor. What is the balance factor? Balance factor BF, balance factor equal to difference from the left child to the right child. So difference number of node at left child minus number of node at right child. So a number of nodes at left child 0, number of nodes at right child 0. So that's 0 minus 0, that is 0. Right child node is B, and one left child, one right child. So 1 minus 1, that is 0. Here node left or no right child, so 0 minus 0, 0. So this is the balance factor 0, balance factor 0, balance factor 0. So this is your balance factor. This is a balance tree, so it is also a AVL tree. But this tree, if you change the combination, that you add another node. If you add another node, suppose I am adding another node at D. What is the balance factor now? Balance factor of D is node left or right node, that is 0. C only right one and no left child, so minus 1, 0 minus 1, that is minus 1. And B 1 left, 2 right, or tips 1 minus 2, that is minus 1. And so in each and every nodes, the balance factor is changing 0, 1, minus 1. At a point, balance factor is 0 minus 0, that is 0. So it is also a AVL tree, because it also maintains the condition. What is the condition? Condition is this difference, the difference BF, difference, that is balance factor BF will be under plus 1, that is plus 1, 0 and minus 1. This system will be maintained, because the balance factor at the O0, balance factor 1 is, so B is 1, balance factor C is 1, balance factor D is 0. It should be 1 between 1 and minus 1. That is 1, 0, minus 1 is the words. This is the balance factor. It must be within this value. So this is a AVL tree. But if we add another node, that is ABCDE, suppose this E, after adding this value, balance factor of E is 0, balance factor of D is minus 1, balance factor of A is C is no right child of the C. So two right child, no left child of the C. So balance factor is minus 2. In case of D, balance factor is minus 3 plus minus 3, that is 1, 1 minus 3, that is minus 2. At the point B and C also minus 2. At the point C, TVLT, condition of the TVLT is breaking. So it is not a AVL tree. Condition of the AVL tree is not fulfilled. So it is not AVL tree, because the C point and the C node is not maintaining the balance factor. So here we have to change rotation. We have to change the rotation of the node. Then this balance factor will be maintained. After rotation, this maintenance will be balance factor. But before rotation, I will discuss the rotation as the next video. I want to discuss some topics, some related matters. That is the height. If this was another child, suppose this was another child is there, and this was another child, EF, BCDEF, and this was another child, substanding value. And what is the length of, what is the height of the node B? Height of the node B is 1, 2, 3, 4. Now 1, 1, 2, 3. What is the value of the BT, height of the BT? Value of the height of the BT is 4. Maximum length from leaf to node will be considered. So this is the actual height of the BT. So when we make difference between the two height, left height minus right height, then we will consider always the maximum length from leaf to node. So this is my end of the video. Just introduction of the AVL tree. Next video I will discuss on details, that is inserting rotation of the AVL tree. Thank you everybody.